In this video, we're going to talk about how to find the area of a region. We're going to be using our graphing display calculators all the time in order to find the area under a curve. Now, what the situation is going to be is that we're going to have a function, which we're going to call f of x or y, right? And we're going to be looking for the area between two values of x. We're going to call them a and b. And the area is going to be between our curve and the x-axis. So it's always going to be bounded under the curve and over the x-axis. This is super important for us to remember. And we're going to be looking at how to use our calculators to find this area. In the next videos, we're going to find how to find the area algebraically, but for now, we're going to use only our calculators to find this area. And there's two ways you can use your calculators. The first method is by graphing it. By graphing it, you plug in your function, and then you can go second, trace, and then the seventh option here is the integral symbol, right? So our integral symbol is for the area under a curve. And then we're going to go and choose whatever the a value and the b value is, and I'll show you how to do this. The second method to find the area under the curve is without graphing. So if you click on your math button on your calculator and you find the ninth option, which is fn integral, then you can right away put the integral from our a to b, and then we have our function here. And I'll show you how to use both of these methods in our example. Example 1. Find the area under the curve f of x is equal to 3x squared plus 4 between 2 and 6. So I'm going to use the first method, which is graphing. So what I'm going to do is I'm going to graph my function. So I have 3x squared plus 4. And then I'm going to go see what that looks like on my graph. On my graph, I see that I have my quadratic, right? It makes sense that it has a minimum point, right? So it's kind of a happy face because our a value is positive. And we're going to be looking for the area between 2 and 6. So 2 is approximately here on my calculator, and then 6 is going to be approximately here. So I'm going to just change my window so that I can really see where the value of 6 is going to be. And I'm going to go ahead and change the window setting. So the x's are fine, but the y maximum is not big enough. Let's change that to maybe 100. And let's see what that looks like. Okay, that's better for me. So I'm looking for the integral between 2 and 6. So I'm going to go on my calculator, second function, trace. The integral is our seventh option. And then what you could do is you could use your cursor to go left and right. However, the most optimal thing to do is just to type in the value you want. So we wanted to start at 2. So I'm going to type in 2, enter. And I want to go all the way to 6. So I'm going to type in 6, enter. And now it shades the region that is the area under the curve between 2 and 6. So our answer here is 224. And let's see how to use the second method. The second method, you go on your regular calculator page, you click on math, and then you scroll down to the ninth option, which is your integral. You're going to have to put your bounds, which are from 2 all the way to 6. And then in the brackets, you need to put the full function. So we have 3x squared plus 4. We're always going to be integrating in terms of x. So here we're always going to put the value of x. And then we click on enter. And we get the exact same answer. So these two methods you can use interchangeably, whatever you prefer. Graphing it does give you a better visual representation, so I would probably recommend this one. Example 2. Consider the graph f of x is equal to 2x minus 2 times 8 minus x, where our function is bigger than 0. So this means that it's above the x-axis. Our y values are bigger than 0. 4 from a all the way to b. So there's specific values a and b where our function is going to be above the x-axis. Let R be the region enclosed by the graph of f and the x-axis. Write down the values of a and b. So first off, let's try and graph this. So I'm going to go onto my calculator. I'm going to just erase my first function, and I'm going to type in this second function. So I have 2x minus 2, close the brackets, open the second brackets, 8 minus x, close the brackets. I'm going to go and graph it and see what it looks like. Okay, I'm going to change my window setting. Maybe the window standard is good enough, so I'm going to choose the zoom option 6. Okay, the y is a little bit too small, so let's put a y maximum a little bit bigger. And now we're going to be able to see what's happening. Good. So what they're saying here is they're saying that there's going to be a certain region that they call R, which is enclosed by the function and the x-axis. So if we look on our graphing calculator, this region R is going from this x-intercept all the way to the second x-intercept. So this region above the x-axis is what we call R. So when they say write down the values of A and B are the x values that start and end our region. So it's another way of asking us to find the zeros of our function. So we can go second function trace, zeros, and then we have to go to the left of our zero, right? And to the right of our zero. And the first zero is going to be at 2. And then we find the other one. So 0, we go to the left of the second 0, and then to the right, and then we can guess, and we get that our second 0 is at 8. So this means that I'm looking for the area between 2 and 8. For part B, write down the integral representing the region of R. So the area R is going to be the integral starting from 2 all the way to 8. And we're going to be integrating our function, which is 2x minus 2, 8 minus x. And for notation, we always need to finish our integral with dx. This dx tells us what is the variable we're integrating. In this course, we're always going to be integrating in terms of x. So whenever you have your integral symbol, we have to close the loop with our dx here. And then double I, hence, find what is this region of A. Well, this region of A, we have two methods that we could use. We could use the graphing or non-graphing. So since I have the graph already here, I'm going to use the graph. Second function trace, seventh option. So the lower bound is 2, enter. The upper bound is 8, enter. And I get that the area is 72. Example 3. Rain is filling an empty water reservoir at a rate of R liters per minute, where R is equal to T divided by 5, where T is the time in minutes. So let's highlight our T is the time in minutes. The graph shows this. Find how much water was filled the reservoir after 1 hour. Okay, if we're looking for how much water and we're given what the rate is, our y value is liters per minutes, and I want to know what is happening for 1 hour, which is 60 minutes. So what we are going to do is we're going to look at 60 minutes. And at this point, if I find what the y value is, this is just going to be the rate of the water. But if I want to know how much water was filled in 1 hour, that's actually going to be the area under the curve, right? Because if you consider this, what you're doing is you're doing liters per minute times minute. That's going to be the units that we have for our y-axis, right? So the y-axis, which is this one here, is our liters per minute. And if we're finding the area, then we're multiplying by the x, which is the number of minutes. And when we do that, we get liters. So for this question, we're going to be using integrals in a conceptual understanding. So I'm going to find what is the integral under the curve t over 5 between 0 and 60. So on my calculator, I can go math and the ninth option. I'm looking from 0 all the way to 60 because I need to have the same units, minutes, and minutes. And my function is x divided by 5. And I always need to finish up with dx. And I'm going to get that in the 60 minutes, there was 360 liters that fell in this reservoir.